Okay, so in this video we're going to talk about exponential functions in the context of a real-world problem. So that means we're going to have some word problems. So the first thing you need to do is read the sentence. So a house that costs $200,000, so that is probably important. So I'm going to box up $200,000. Will appreciate, that's a keyword because appreciate means grows. So we know we're going to have an exponential growth function. And then they give us a percentage each year, okay? The percentage is probably the most important thing of that. So write a function that models the cost of the house over time, use x for years, and use y for the value of the house. So again, when we write an equation, we're going to have y equals a times b to the x, okay? Where a is your initial value and b is your growth factor. So here is our initial value, because that's what it cost. So I'm going to start with y equals 200,000. I missed a zero in there, okay? To the x. So now you need to figure out the growth factor, okay? And this right here is called the rate. And then we need to remember how to go from a percent to a decimal. So again, if it was 3%, when you change that to a decimal, you either divide by 100 or you move the decimal 2 places to the left. So that is the same as 0.03. So 3% is 0.03. So again, you can divide by 100 or move the decimal 2 to the left. So this is the rate. Okay, but to find the factor, you either need to add 1 or subtract 1. And since it's growing, you're going to add 1. So I would add 1 to my rate to get 1.03. The reason I add 1 is if it's growing, I need that number in the middle to be bigger than 1. Okay? So once you have your equation, then you need to figure out how much was the house after 10 years. And so I'm going to substitute in now. So I would have y equals 200,000, 1.03, and you're going to plug in 10 right there. So you're going to raise it with that little arrow button to the 10. So I'm going to give you a second to type that in, but you should get 268,783.28. So again, if you did not get that, please let me tell you how to type that in the calculator and press pause. So otherwise, that's how you write the equation and that's how you evaluate. So let's take a look at another example. So the most recent virus that's making people ill is a fast multiplying one. On the first day of the illness, only 2 bugs are present, okay? So that's probably going to be our initial value. That's what we started with. After each day, the bug triples. So triples, think about triplets. You've got 3 kids. So that means it's going to be multiplying by 3, okay? So that's actually our growth factor. So if they give you a number like triples or doubles or quadruples, they've given you the growth factor. So I'm going to write my equation. So y equals your initial value, 2, times your growth factor, 3, raise it to the x. Okay? And then I want to find the amount of bugs present on the 5th day. So I'm going to substitute in right there and get 2 times 3 and raise it to the 5th power, and you should get 486 bugs. So again, try that in the calculator, and if you did not get 486, please let me know. Okay? Let's look at another problem. Tobias ate half a banana in his room and forgot to throw the rest away. That night, 2 gnats came to visit the banana. Okay? So that's what we started with. We had 2 gnats to visit the banana. After each night, there are 4 times as many gnats. So that means my growth factor was a 4. Okay? So when I write my equation, I would have y equals 2 for the 2 gnats I started with, and then it 4 times bigger after that. Okay? And we are actually going to skip this problem down here. Okay? So I just wanted you to write the equation of that. So let's turn the page and take a look at some other examples. Number 4, it says you have a bad cough and attended your sister's little your little sister's quiet concert. You take cough drops that contain 100 milligrams of methanol each drop. So that is probably important. Every minute the amount of methanol is cut in half. So that is also important. So the 100 milligrams is your initial value because that's what you started with. And then this half is going to be your factor. It's important to notice that that is going to be a decay factor because half is going to be smaller than a 1. So when you write the equation, you would have y equals 100 for your starting value. Half is your factor, raise it to the x. Okay? And then we are going to skip this one too. Number 6. Jacorian is 60 inches tall and growing through a growth spurt. So 60, probably going to be your initial value because that's what you started with. For the next year, his growth will increase by 1% each month. Okay? So it said increase, so you know you have a growth factor. Okay? But remember, the percent is your rate. So what you have to do is, again, to go from percentage to a decimal, you can move the decimal twice and get 0.01, or you can divide 1 by 100, and 1 divided by 100 is 0.01. Okay? So once you have your rate in a decimal form, you need to add 1 because it's growing. So then your growth factor is going to be 1.01. Okay? So we can write our equation now that we have our growth factor. So we'd have y equals, he started out with 60 inches. Our growth factor was 1.01, and then I raise it to the x. And then find Jacorian's height at the end of the year. So we need to know that 1 year equals 12 months. And since it said he was growing each month, I'm going to use 12 instead of 1 year. So I would say y equals 60 times 1.01 and input 12 for 12 months. When you type that in, you would get 67.61 inches. So that is what he would be after 1 year or 12 months. Okay. All right, one more problem. And this is going to be an example of a decay problem. So it says Ian's new Mercedes cost him $75,000. So that's going to be our initial value. That's our starting point. The moment he drives it off the lot, it will depreciate. Depreciate is a keyword for decay, because that means it's going to be decreasing. Okay, so it's going to decrease by 20%. So the first thing I need to do is change 20% into a decimal by dividing it by 100 to get 0.20. Okay, so this is now my rate. Okay, for a decay problem, you have to, again, find the decay factor. And to do that, you have to do 1 minus your rate. Okay, so on the previous problems, I've always added 1 to my growth factor. So up here, again, I added 1 because my rate was 0.01 because it was growth. If it's decay, you're going to do 1 minus that number. So I would do 1 minus 0.20 to get 0.80. Okay, so that is the number that's going to go in your parentheses. So when you write a function, you're going to start with that $75,000 he did, but you're going to put 0.80 into your equation. Okay, so like I said, if it is a decay problem, once you find your rate in a decimal, you do 1 minus the rate. You do not add 1 to the rate because even though that number is smaller than 1, the factor is how far away it is from 1. Okay, so the final problem it wants to know was the cost after 5 years. So again, you will substitute in 0.80 and type in 5 years. Once you do that, that car is going to be worth $24,900. Okay? So this is an excellent real-world problem of exponential growth and decay because this is true. If you buy a really expensive car, after 5 years, it's going to really lose its value. Okay? So now you're going to practice with some more examples. Again, raise your hand. I know these are a lot harder because you got to do more work. Again, the decay is probably the hardest because you have to do 1 minus the rate instead of adding 1 to it. So get started on your practice. Let me know if you have any questions.